Hello and welcome to another episode of Adventures in .NET. I'm Sean Claber, your host, and with me today, your other co-host, Christian Wens.
Hi everyone.
Hey, Christian, how are you doing?
Very well. It's
Yeah,
been a long week, but
yeah,
excited about what's to come in the next hour or so.
yeah. Did you do anything for Halloween?
Uh, I did. So I joined a group for trick and treat, probably the second time in my life, and I didn't want to like it, but I had a fantastic time.
Oh,
So I'm hooked now. I'm hooked
uh,
now. How about
great.
you?
Yeah. Well, I mean, stayed around the house. I do a fair amount of decoration with programmable lights and yard displays and things like that. So it's kind of fun. We didn't get a whole lot of trick or treaters this year, but it's typical. We don't get a whole lot because we're kind of like on a dead end street that's houses only one side of the street. So a lot of kids don't like to walk down the street just for a couple houses. So, but it's still fun. It's my favorite holiday because it's so interactive. So
Excellent.
yeah, so that works for me.
All right.
Let's bring out our guests. Let's welcome Dan Milicic. Did I get that close?
Yeah. Hello. Thank you for
Yeah,
having me. I
yeah.
I think this could be my second time here, but I'm not sure. It was long, long time ago.
It's a long-running show.
Yeah, we had Oren on one of our early episodes and things like that. So we've had some episodes. We're talking about RavenDB this week, so we have talked about that. So why don't you kind of give us a little bit of introduction about yourself, who you are, what you do, and then we can move on to the topic from there.
So I'm currently leading DevRel department at RavenDB, and this is interesting position because it's kind of heterogeneous. I'm doing coding, I'm maintaining community, I'm creating demo examples, or as I like to call it, I'm still coding but without deadlines, which is perfect for me. I like coding. I decided when I was something like 12 or 13 that I want to be a software developer, and it was back in the 80s. So here I am, like many years after that, still coding and still enjoying it.
That's actually fantastic, right? If you still enjoy what you're doing after all that time. I think, especially in the last couple of years, I saw many long-time developers just move into other things for a variety of reasons, right? And I mean, all of those may have been valid reasons, but I always admire it if someone still enjoys doing what they do. Um, so thanks for being on the show. And given your position, it might be that we are talking about RavenDB or even more general about NoSQL today. And I mean, this SQL versus NoSQL debate is probably as old as NoSQL is, right? Or NoSQL. So I have a hunch what side you're on, but maybe if you would give us some insights, what made you pick what?
Sure. So back at university in mid 90s, I was learning relational databases, and all these formalisms and third normal form. And then
And
as
yeah,
young
more than that.
person, yeah, definitely. So as a young person, you exit university and you enter actual real life, and then you start discovering that things are not so quite streamlined as you learn in the classes. So the first time you join 8 or 9 tables, or 7 maybe, to show something on the screen, you start realizing, okay, this is not all flowers and roses. This is real life. And well, when you look at it, relational databases were incepted in something like 1971, where Professor Cod, came out with a paper, famous paper. Before that, you had something called navigational data model, and relational databases were so revolutionary because this was the first time that your data structures in the database were actually detached from underlying hardware. So you could say that this was first major abstraction of the data, and this is one of the reasons they were so successful. And it took, this is now interesting, 71, and first relational database was out in 1979. It was Oracle, and of course, now you can see why it is important to be first in the area. And, even today, Oracle is a big name, and they shifted to big governmental organizations, and, they're big guns. And then there was interesting story. Cod was working for IBM, and he comes up with a paper on relational databases. Oracle implements it, and customers of IBM now starts craving and asking for a relational database. And after 2 years, IBM gives up, and I think in 1981 comes out with their own relational database. So they had the gold in their hands, and they managed to slip it a bit. And then 80s golden era of relational databases. And this period in time, if you think about it, it was quite different from what we have now, because there were few developers. When you think about it, personal computers were still making their way in like 1983 or 1984. Spectrum, ZX Spectrum, Commodore 64, and you as a developer, now you're building application, and you have precisely defined audience. So you go to you're working in some organization, and we have 250 employees. This will be my user base, and let's say we are growing 10% year after year. So I have precisely growth rate charted, and life is good for me because things are much more predictable. I know what kind of data these 250 people will enter in the database, what will be the shape. I have a limited user base, so no need to prepare, big scaling. Still no startups in today's sense. So life was, you could say, different, significantly different in the 80s. And then in the 90s, you have internet emerging and Java. I'm so old. When I enrolled at the university, Java was not existing. This is interesting point. And
when I enrolled, it was kind of brand newish, right? So we were all excited, but the curriculum that kind of went along with Java was pretty dated and wasn't using standard terms for standard OP concepts. So that was rather confusing. But yeah, I was an early adopter, and I still remember that. I think the apps method, the math apps method, was only introduced in Java 1.5. So I wrote code for my thesis, and it required a pre-release version of Java to run. That was kind of my approach to avoid that someone tries to run my code. But that's a different story for a different podcast. So please proceed.
Yeah.
Sorry.
Yeah, I know what you're talking about, though. My first classes at university were with Pascal, Fortran, COBOL, and just plain C. So that's what they taught me at university. Yeah, so I can relate to you there.
But of course, now you can connect like Java applets, and today WebAssembly, WebAssembly, Java applets made right. In the end, we will reach Java applets ideal, but through WebAssembly.
Yeah. It's sad but true, I guess. Yeah.
Anyway, with the emergence of the internet, it's suddenly completely different story. Lots of parameters you cannot control anymore. Things are not predictable. You create a website or web application. You go somewhere, advertise. You become popular. All of a sudden, you have search. We all remember all these stories of sites going down because too many people came to visit, to look around, to shop. Even today, when you look at it, Ticketmaster, I think it was a year ago, had a problem selling Taylor Swift tickets. And you could think, okay, this is 2022, for example. I bet these problems have been solved. But you see, these are inherently hard problems, but potentially infinite scaling of users coming to your website. And in early 2000s, you have emergence of Google, Yahoo, Pinterest, all these companies. And imagine Google, for example. Our goal is to index whole internet, which is exponentially growing. So simplest possible question, which database we are going to store all these pages our web crawlers are visiting? So those are unique challenges. And this was some kind of emergence of idea, okay, let's create specialized solution for this unique challenges. And this is how NoSQL movement emerged. Now, with SQL, you had standards, you had SQL as a language, you had this theory, standardization. With NoSQL, company after company, team after team tried to solve specific problems. And this gave birth to a very heterogeneous ecosystem. So you have various kinds of NoSQL databases. It's like a zoo, and solutions are specialized. So, for example, you have document NoSQL databases where you take object or graph of your objects from the memory, you serialize them into JSON or some other format, store them in the database. Then you have, for example, solutions like Cassandra, which are not only scalable in the number of the rows, but also in the number of the columns. Then you have graph databases where connections between the items are more important than the items themselves. But all of these solutions, and let's not forget the Redis, all these solutions are specialized and they are giving good results if you apply them in specific scenarios. So going back to your question, on which side I'm on, I'm trying not to, as I call it, drive on autopilot. I try to look at every single project separately to determine pragmatically what is the right thing to do, what problems I have. Do I have, for example, full text search need? Am I working with business intelligence department where people are running something like Tableau and are at home writing SQL scripts for aggregations? So I would say NoSQL movement is kind of pragmatic, non-dogmatic movement, which is even for using relational databases when it makes sense.
Excellent. I like the pragmatic approach, right? So if you have this one size fits all, once I have a hammer, all the problems are nailed, right? Approach that just doesn't cut it. Still, you decided to work for and on RavenDB. So I mean, when RavenDB was invented or incepted, right? There were other NoSQL databases already, right? So what was kind of the motivation to build a new one?
So this is an interesting story, which probably Oren mentioned a bit, but it was fascinating to me to follow because I was following Oren and what he was doing, and then I started using database, and then I got very passionate, and then I joined the company. And it's always nice when you have this sense of ownership and when you can see that your acts and what you're doing has effect. So actually, Oren started as open source contributor on an Hibernate project, and of course, when you're working on a project like that, you learn all the fine details of relational databases. You get a lot of knowledge, and of course, then what would be more logical than engaging as a consultant? This is precisely what Oren did. And after some time, as he wrote on his blog, it was the case, he enters the company at 9 a.m. in the morning, and by lunchtime, he already spotted a couple of anti-patterns that developers are using there. And you know what every good developer will do? Well, he tries to automate it. So his first step was to write some profilers which could automate, recognition of these anti-patterns that people are using. So that would be full table scans, queries without indexes, or select n+1, which is most common when you're using some kind of ORM. And then, you go from company in company and you see the same problems. I myself experienced after, 10, 15 years of working with relational databases that I still have problems. I still have challenges. And it was always like my reasoning, okay, it's up to me. It's not up to technology. I need to sit down and read a couple more things and learn things, But it turns out, even if you're an experienced developer, if you're knowledgeable, if you know about the indexes and all these fine details, you will still run into problems. And this is precisely what Oren noticed. And then, as a second step, okay, I have tool for automated detection of these problems. Now, how these problems could be prevented. And he started looking at the CouchDB. And he liked it. He started playing with it, and then he decided, okay, let me throw up a toy project, because every good developer has these ideas haunting him all the time. And you walk around, you go into shower, you think, and it could be sometimes you're thinking for like 6 or 9 or 12 months about something. I'm pretty much sure that was what Oren was experiencing. And he started, I think it was something like September 2009. He opened repo and started working on it. And a couple months later, RavenDB was born.
Actually, from the timing wise, that's pretty amazing, right? Because I mean, then so it was born 2009. I think the first version came out 2010, if I'm not mistaken.
Correct.
And I mean, CouchDB at the time was already a few years old, but I think version 1.0 of CouchDB was also released in 2010. I was at the OSCON conference in 2008, where and at least that's what they said back then. I still remember that vividly, where they said this was kind of like the unveiling basically of CouchDB, or one of the first public large scale conference presentations on that matter in 2008, right? But 1.0 came out in 2010, I believe, even later than, or maybe at the same time at RavenDB. RavenDB's first version. So that's pretty amazing, right? So at this one point in time, there were all of these kind of innovations and approaches to NoSQL, right?
Yeah,
Because
probably it goes like that, some kind of, it was such time, like lots of innovations, people thinking out of the box. Then you had, if I remember correctly, Ted Neward with polyglot programming, like this sense that you could have a team divide into like some kind of service-oriented architecture. Microservices back then were not yet hot thing, and then you could build different services in different languages and establish messaging, some kind of messaging between them, and this could work. And for example, even today, if you work with AI, most probably you will go with the Python, because this is where you have most resources. So it was interesting time back then.
Absolutely. And so you've come a long way since then. What's the current version number of RavenDB?
It's
November
6.0 out on
6.0.
October 2nd. And this is interesting. It contains a couple of features that took 4 to 5 years from the first idea to, from inception as an idea to implementation. So for example, sharding is very interesting, because sharding is empowering you to eliminate this, roadblock along the way. Let's say you're a big company, you have large database, and it's now measured in terabytes, and you have corporations which can extrapolate at which point in time, maybe even month of a year, they will hit the limits of their database. And on top of that,
so sorry for interrupting you. So for those of you of our listeners and viewers who are not familiar with the term, right? So maybe we should quickly explain that. So sharding essentially is that if you have data or even a data set, you can distribute it to different even database server instances or databases. Correct. Right? Yeah.
So the moment for sharding is the moment where your database or your data set is bigger than the biggest disk, essentially. So let's say, let's assume the biggest disk you can get is, I don't know, 8 terabytes, and then your database is approaching that limit. What will you do? Sharding is the approach of splitting database into smaller pieces and then distributing these pieces across multiple machines. And that's okay, but the really hard problem is how to make this internal implementation details so that people using this database do not observe any changes. So your decision to shard database into different pieces shouldn't reflect on the queries you're writing. You shouldn't be writing 3 queries and sending each one to different shard. Database sharding orchestrator or coordinator should do that. So you send a query. This query is distributed to all different shards. These shards compute results, return to the orchestrator. Orchestrator combines all of that together and responds back to you. So the hard part is actually not this process I described. The hard part is actually making this completely invisible to the user. So the moment, let's say you cross over, let's say 10 terabytes, and you decide to shard, you perform this over a couple of days, you switch the switch, and in ideal case, your code base will remain the same. That would be some kind of the holy grail of the sharding. So you're able to make this transition without changing the code, because we all know as developers, when you mention refactoring or reimplementation of existing things to managers, they won't be so happy. From their perspective, this is already working. Don't re-implement it. Don't refactor it. Let's implement something new, which will bring us money. So then, as a developer, you need to fight your battles, and you need to combine it. In ideal case, you do something like 80% of new things, and then each week you have, let's say, 1 day which you devote for cleaning up your code, and you have a large list of your technical debt, and you slowly go and fix it before it brings you in an unfortunate position.
So is there a lot of
Sean,
decisions? A lot of decisions that you have to make for sharding it. Like with relational database, you can just basically add a disk, and it'll just expand the data files onto the other disk and continue on. You don't really have to think about that much. But is there more that you have to think about when you're sharding something?
Well, it goes from the database to the database. It could be so sharding could be based on, let's say, hashing the primary key or identifier. It could be based on, you could also say in today's world with GDPR and all other regulations, you could also say, I want geographical sharding. So everyone of my customers who is in Germany, servers must be on German soil, on German territory. I will shard my customers based on the geographical location. The problem is, with most databases, you make the decisions once at the moment you shard data on different servers, and that's it. And it's kind of, I wouldn't call it a gamble, but you're making decisions, and you will feel the consequences later on. So if you picked up a wrong sharding strategy, you may end up, for example, with one single obese shard, which is taking like 85% of your data, and it can be unpleasant. So what really matters here is, and why it took us, for example, 5 years to come up with the final implementation, is thinking how you can introduce sharding to the database that wasn't supporting server-side sharding up to that point, how to integrate it, and how to make this transition seamless so that you have an application, you point it to the database which is sharded, and it just works. And this just works moment is essentially the hardest thing. And what is, the most strange part about this, you can spend years working on something to make it just work. You deploy it, and people say, okay, nice, it works. So I compared once a database with the window. When you will notice window on your home or on your house? When it's broken, when it's dirty, when there's something wrong with it. So database is like a window. If it's working properly, you will not notice it, and this is what you're expecting. This is the normal state from the user's perspective. This is piece of infrastructure, and it works. When was the last time you were thinking about electricity? It was either because it was missing, or it was too expensive. So databases are now becoming, especially with Postgre, if you observe what's happening with Postgre, databases are slowly transitioning into this kind of infrastructure. And on top of this infrastructure, you're building various things. And this is good because you have a solid engine, and then you're coming up with new things on top of it. And until recently, I wasn't aware of FoundationDB. I don't know if you're aware of it. So this is very interesting. First interesting thing, This is database acquired by Apple, and then Apple released it as an open source, which is quite interesting. Taking
Quite
account.
unusual indeed, yeah.
Yes. The second interesting thing is that team behind FoundationDB and the name Nomen is Omen, as Omen, they intended from the beginning FoundationDB to be the base kind of engine, and then on top of it you can build a relational, non-relational graph, etc., vector database these days. But what is interesting, what they did, FoundationDB team spent a year or two building a virtualized environment where they could produce deterministic environment for execution of the test code. So it was like TDD to extreme. They built a whole virtual environment where they could say, okay, 10% of the calls to the disk will fail, or there will be occasional, 5% of TCP IP calls that will be slow, or this percentage of the packages will be lost. And this provided a way for them to have deterministic, to write tests and achieve things. And similar thing is with the RavenDB. I don't know how many thousand tests. I think over 20,000 tests, integration and unit tests. Tests are present, and they are running every night. So you have nightly builds, and they are running.
So if you shard an existing database, is that an online process, or is that done in the background, and then once it's done, you switch over?
So with RavenDB, when you are creating new database, you need to decide, do you want this newly created database to be non-sharded or sharded? Let's imagine this process of a company working with a non-sharded database for a couple of years. How you would do transition? Well, simply speaking, you would create another one, which would be sharded, and then you would be establishing your RavenDB ETL, which would be on an ongoing basis in real time pumping data from a non-sharded database to your future one. And when this is done, you can switch your code pointing to sharded one.
Okay.
I somehow remember, but I mean, maybe I'm wrong, so feel free to correct me. I thought that there was sharding in an earlier version of RavenDB before, but then was removed. So was that because you found out kind of limitations with the implementation, or you found those edge cases that made it really hard?
So actually, this shard, you're very correct. This was something like up to version 3.5. Let's say up to 2015, something like that, which is ancient history now in our profession.
Long time ago, yeah.
Actually, this sharding was client-based. So the client would determine to which, okay, I'm sending document to be saved, and then I'm determining based on the various parameters to which shard I want this to go. You can do the same by altering you can direct still. Now in version 6, you can say, okay, I will create IDs which will direct document to specific shard, but you don't have to do it. If you leave everything as it is, like convention over configuration principle, it will be working out of the box. Since we are using hashing over primary keys or identities, as they are called in Raven, this will help unique distribution of the documents over the shards.
So now version 6 has the sharding feature built in. You mentioned version 3.5 from 8 years ago or so. So which versions of RavenDB are still under support? So what's the support policy?
So from time to time, we release LTS, long-term support versions. One of them was 4.2. Now we have 5.4. And
so you do it for minor version numbers that you assign LTS.
Yes.
Okay.
Usually,
not like what
major...
.NET is doing. Like we just are just new major version each year, justified or not, and then every second is.
It's a bit calmer here. So the thing is, you release major version like 5.0, and then you stabilize it, and then you say, okay, this is now stable enough for the long-term support, and then. For example, 5.4 is now long-term support. when new LTS version comes out, 5.4 will have 1 more year of support.
Okay. Okay.
So I was just checking.
Yep.
Yeah. Oh, go ahead.
No, all
You
good.
follow up? Okay. I was just checking that Oren was on episode like episode 27 of Adventures in .NET. So that was May of 2022. What version would have been back then, and how much has changed?
I think 5.3, but actually the biggest technical change. So sharding is the feature we are offering now, but the biggest technical change after 13 years, and probably people not enough people know this. Internally under the hood, you have 2 data storages. One of them is the key value store. So when you're saving your documents, they will be stored in ACID compliant manner, which is also a bit controversial with NoSQL databases. Still, to this day, lots of people think that NoSQL equals missing ACID compliance, which is not true, of course. There's no reason for any database not to be ACID compliant. This is the cornerstone of reliability. And MongoDB in the beginning, they decided to ditch ACID compliance, and there were
I think
jokes.
FoundationDB was kind of advertising that ACID compliance is like one of the key assets, right? But so RavenDB has that as well.
The second major component is the indexing engine. So you store something is going to the key value store. You run query, it's going through the indexing engine. So what team did, they selected Lucene.NET to be indexing engine. They forked it. They made it ACID compliant again. So the Lucene.NET fork of RavenDB is also using key value store, ACID compliant one. And out of the box, you get a very powerful mature engine, very well written. You get full text search capabilities out of the box. And this is interesting when people are contemplating, shall we use this new piece of technology, new piece of infrastructure actually? And it's always critical in any organization. I go and tell them, okay, try it on full text search task, because Lucene.NET is inside. It can support wildcard searches, spatial searches, spatial indexing, custom analyzers, custom tokenizers, basically everything. You will see on this small, low-risk task, you will give it a test run and you will see how it's working. And now, after 13 years, we developed new indexing engine called Corex. I think that's the Raven in Latin. So now in version 6, we have...
Actually, it is, yeah.
We have parallel existence of Lucene.NET and Corex, and this will be, I think, up to the version 7. So what we did, over the years, we tweaked, changed, polished Lucene.NET. We learned lots of lessons. And then we applied all of these lessons to build new indexing engine. So we actually managed to solve some challenges or shortcomings Lucene has. So for example, Lucene is primarily full text search indexing engine, and in its nature is to process individual documents. With the database, when you think of scenario of heavily writing to the database, you will be processing things in batches. So Corex is first and foremost oriented and optimized to process batches of documents. Then, Lucene is building lots of in-memory structures. With databases, basically all databases are relying on either B+3 or some variant of it, which is, again, probably something like 40 years old idea. There's no magic. Basically, with databases, you try to pre-compute as many things as you can in advance to form these inverted data structures, to create indexes. And for older people, for younger people, not old like us, index is like a phone book. And if you don't know what phone book then you're young. So basically what was done here, all these data structures that Lucene was creating in the memory, we are now putting them on the disk, which means that if Lucene is taking 8 gigabytes of RAM, Corex will take just 1, because the 7 gigabits of RAM which were allocated for inverted data structures and all these posting lists and all the other data structures, this is all now on the disk. So this means that less memory is allocated, and also cold queries. This would be query which you run after writing to a database. These cold queries were taken unproportionally long time with Lucene. Now they are very fast because everything is prepared on the disk, waiting, and you just need to execute. And this is something that took, I think, 2 or 3 years to implement it. Now it's mature, now it's released. But it's interesting, you can imagine developers, team that was developing Corex, they're working for 2 or 3 years solving really, really hard problems. Because you can imagine, you're building an engine that will be powering sharded databases, and maybe this will be 50 terabytes database, and you can imagine how testing something like this works. So we take Stack Overflow dataset and load it. Actually, a challenge for itself is finding dataset large enough, realistic enough, with a proper statistical distribution of data, so you can run tests on that. Most people are not even given a thought. Something like, for most projects, 3, 4, 5 gigabytes is large enough. We are speaking here about multi-terabyte data sets. And this means, for example, on one occasion, I was loading a large data set. So I took Reddit export of users and Project Gutenberg. So it took me something like 4 to 5 days to load 1.2 terabyte of data to the database so I could run some benchmarks. So you can imagine just 24/7 loading, parallelized code, loading of this data into the database. You can imagine like 4 to 5 days, how much data that is.
Do you see a day where we can query our databases with a natural language? Like I'd like to talk to my database just like I talk to ChatGPT.
Certainly. I see no technical obstacles to it. Because when you think about it, look at something like Wolfram Alpha, again, something that's not so popular, but Wolfram Alpha started as a software called Mathematica, I think, back in 90s, symbolic computing, and now you have Wolfram Alpha website, which is loaded with lots of data, and then you can go and say, give me all Super Bowls where next Friday you had rain. Because in Google you can search for answers that someone already gave, but whole different areas computing these answers. So you can come up with questions that no one answered yet, and data is there, and Wolfram Alpha can process this in a symbolic manner and answer. When you put something like ChatGPT on top of that, I think that you have technical conditions to have natural language question, which will be translated to lower languages and then executed. And when you think about it, we first introduced assembly programming language, then higher programming languages to make, and then you have compiler, which is actually translator between higher programming languages and lower ones. So I see no obstacles in multi-step, multi-phase translation from the human language down to some lower forms and then executed on the dataset. And I don't know how that future will look like, but I'm eager to see it.
Yeah, me too. Most of my work is done with relational databases. And so if I never had to write an actual SQL statement anymore, that'd be fine with me.
So this
Isn't
could
that why
mean
you're using an OR mapper, Sean?
Yeah, pretty much. But
what may happen is that Alexa will be revived when this happens. Usually you have this when you look at some very successful startups, like, for example, Airbnb. Premise of the Airbnb is literally, you're not at home, leave the keys to a complete stranger, enter your home and use it while you're not there. But it turns out that Airbnb was started at very good point in time historically, and they succeeded because of that. If I'm not mistaken, Uber before Uber was one German company which had problems, I think, financing, and they did not succeed. So, for example, it could be that Alexa and similar devices were released ahead of time, and they missed this artificial intelligence or LLM revolution. So they could be back.
Yeah, I think I could be wrong, but I think VRBO was out before Airbnb, because
I'm pretty sure,
VRBO Verbo is vacation rental by owner. So yeah.
Betamax was technically superior and failed to VHS. So life's not fair always.
HD DVD. Anybody?
Exactly.
Yeah. All right. So what's the future of things like RavenDB?
Well, on one hand, databases are becoming actual infrastructure, and you can see it, as I said, with all these initiatives which are building on top of the databases. But I think something that exists in RavenDB and people are not aware of is something very interesting. This is possibility for you as a developer to write a C# static method or JavaScript, piece of JavaScript code and inject it inside of the database. And this is interesting because this provides you with almost infinite scalability and extensibility, because you can have some complicated calculation, you can implement it in the programming language of your choice, and then you can plug it inside of the database. So now you have vector databases. I don't know if people are aware of how they are working, but for example, you have two products. And you can see that sunscreen and sunglasses are sold together, but how you can collect all these products which are sold together. So you establish something like 40, 50, 80 attributes or characteristics. You grade products by each of these attributes, and then you essentially form a mathematical vector with all these values and the attributes, and then you can compare them. So I think extensibility of database like RavenDB is very important, because vector databases are now in and they are specialized too. But if you can provide extensibility points and let developers react quickly, swiftly when something new is out, I think this is great, because you are giving some kind of security to people using your database that they will be able to quickly accommodate.
I've got one final question with regards to RavenDB about the stack. I mean, RavenDB is proud to be using .NET as the implementation stack and framework of choice. So which version are you on at the moment?
We're currently on the version 7. So
Okay.
the development, our CTO is actually a real developer, and I'm joking that I was writing business, line of business applications, but this is really hardcore programming. This is what most young people are dreaming of. So we are following .NET team. We are using version 7. After version 8 is out, we will, of course, first internally migrate, test it, see if everything is okay. But I could tell you that RavenDB is actually profiting from all these speed ups in .NET Framework. And it even comes to the point that we did some optimizations, which are now built inside of .NET Framework. So we have to remove them, because our optimizations on top of .NET Framework optimizations can sometimes produce worse results. So we actually need to roll back some of the code to the simpler versions to be able to fully leverage ahead of time compiling and now these PGO and all these optimizations. So I think the work that .NET team is doing is quite impressive. It's amazing.
All right, and so you always aim to use the latest released version of, or stable version of .NET then, just because I think since .NET is, I mean, some people maybe disagree, but is close to being feature complete, right? Performance is, I think, one of the key initiatives of the last couple of releases, and you directly benefit from that.
Correct. And also, one interesting thing, when you're building a database, technically speaking, you have operating system and then you have a database in the terms of how close you are to the hardware. So actually, when you look a bit, RavenDB is open source project, and you can see pull request. Everything is transparently done. And I'm usually saying, okay, it's not just like license open source, it's the spirit of the open source, transparency, you know. So you will see that our team from time to time discovers bugs in Windows, bugs in Linux distribution, bugs in .NET Framework. And it's quite interesting because, you know, when you're building business applications, when you have a bug, it's you. Here you have whole stack and you're working close to the metal, and then you can be hit by something like that.
That's pretty cool. Awesome. So you're anticipating .NET 8 being released in 2 weeks with, once again, nice performance gains?
Yes. So this is nice. Of course, when you think conceptually about the database, it's people will assume it's written in some kind of low-level code. Maybe C nowadays, maybe Rust, because I see Rust is next C. But C# is completely, totally unexpected choice. But now you see for small optimizations, you go with small moves. For big optimizations, you cannot go to something like C and Profit. For big optimizations, you need to think about memory allocation, memory arena, avoiding garbage collector, you know, all these kinds of large-scale optimizations.
So you mentioned about putting code in the database, and, you know, myself not being totally familiar with using NoSQL database, things like that. Would that be used for like creating something like a calculated field or things along those lines? Is that
you can calculate the field even without that? But let me give you an example. One of the demos I did a couple of months ago. So what I did, as every good developer, I'm a bit lazy. So I found on GitHub someone who implemented trained machine learning model for labeling images. So essentially, this person created a Dockerized API. You send as a payload to the API, you send image, bytes, actual content of the image, and trained model will return labels and probability. So it will say, okay, 70% that you have a ball on this picture, and 80% that you have Volkswagen Beetle, etc., etc. So with such model, what I did, I took my database, I wrote small piece of code, which is establishing HTTP connection with REST sharp to this Dockerized API. I plugged in this code into RavenDB, and then I got an index, and this index will take images because RavenDB can store images as attachments. So this index of mine takes images from the database, sends them to Dockerized API. Dockerized API responds by sending labels with probabilities. And then for everything which is more than 50%, I store that inside of the database. And after that, I can go and simply say from index, images by label, where label equals penguin, and probability is greater than 0.9, and I will get all images where most probably I have a penguin or whatever. And now when you think about it, real life examples, imagine airport security, imagine database which is storing all these photos and the videos, and then imagine virtual helper to the person looking at security screen, firing up a red light because something is suspicious on this image, pay attention, or with the doctors analyzing X-ray or MRI scans. So for tasks like that, imagine now you have completely extensible database that can talk even. You can go and, if you want, you can hit over the network AWS some kind of newly released service by AWS or Azure or GCP.
Very cool. Very cool. So one last question is, RavenDB, does it have different editions? Does different licensing apply? Like there's a free edition. There's in it, like if you're using it in like Azure, is that different than if you try to install it into an on-premise server?
You can install it yourself. As a developer, you have developer license. Just register with your email and you get license. There's community license, which is suitable for commercial projects. So let's say you're a small startup, you have your hobby project. You can use community license to run it completely for free. Or you can go to RavenDB Cloud, which is database as a service. You have free OneNode cluster there. So again, you can spin up a cluster of OneNode and start working with your database. What is interesting is that this is quite capable database. It runs on Raspberry Pi, even on AWS Graviton, on ARM processors. So even small humble instance that you can get for free in RavenDB Cloud is able to support decent sized projects.
Yeah. So, I mean, how big can a one node instance of RavenDB, how big of a database could it be?
On one node, you can, in RavenDB, usually you go with a cluster of 3 nodes. We are using Raft distributed consensus algorithm, so odd number of nodes is recommended because of the voting. So each of the nodes is holding complete replica of your database, so you have high availability out of the box, something very similar to Kubernetes. So if you're going with a single non-sharded database, somewhere around 10 to 12 terabytes is some kind of natural limit. But as I already mentioned, most databases I can see in production are in gigabytes or dozens of gigabytes. It's very rare. I think less than 1% in the database in the wild are over 1 terabyte in size. So actually, with one small humble instance, you can go a long, long way. Probably you will reach some kind of position where you will be glad to go and actually purchase bigger instance, and you will be glad that you can solve your problems with money.
Yeah. So, but if redundancy and uptime isn't so critical, then a one node instance could get you by until you get to that point. Yeah.
Or you can go with embedded version where RavenDB is running in SQLite mode in the same on the same machine with your application.
Okay. Very cool.
Excellent. That was very, very insightful. Thank you very much. Are we ready for picks, gentlemen?
I think we're ready for picks. So, Christian, why don't you go first? What's your pick?
I have a software package that just came out with a new version. It's about PDF tooling. It's called PDF24, or the suite is called PDF24 at pdf24.org. I think the team that does that resides in Berlin, capital of Germany. But don't worry, the software is in English as well. And so it's basically a collection of tools for PDF, like, combining pages, extracting pages, rotating pages, watermarking pages, deleting pages, etc., etc. And it's all free. And I know there's kind of an abundance of online tools that does that. And yes, they do that online as well if you want to. And if you want to upload your top secret PDF documents to random sites. But they also have this as a Windows application, which you can download and install. And again, it's all free. And I mean, most of the time, I have just to combine different PDF pages, and there are other tools for that as well. So I wouldn't rely on that. But for all of the other extra options, I think that's probably of all of the available PDF tools, probably the best one and actively maintained. So by all means, check it out.
Okay. All right. Dan, what's your pick?
So I will pick something which is not related to the screen of the computer. Since every developer I know is dreaming about building his own product or company, I will pick up Shark Tank, which is a show where people are pitching their ideas, their business ideas for startups and for products and services to investors. It's entertaining for me, and I also think by watching it, you can start thinking a bit from the business perspective, what is important for running business, for succeeding, etc., etc. So I'm really enjoying it.
A nice show. Actually, the German version is called, if you translate it, Lion's Den. So depending on, I think, where you are, you have different metaphors for that that area you enter about to be eaten alive.
Yeah, I think I've watched probably every episode of the US version of that since it started. So I've kind of got a little bit of an invention, bug that's in me that likes to build things and create things and whatever, and have some ideas that I want to productize, whatever. So I learned about it, but will I ever happen? I don't know. Maybe, maybe not, but I learn. So my pick this week is kind of a guilty pleasure. It's a show on Amazon, not on Amazon. Yeah, it is on Amazon. So it's season 3 just started for a show called Upload. It's kind of a really corny comedy show, but I don't know. It's interesting to me because it's about this guy that got killed, and right as he got killed, they uploaded basically his brain into this virtual environment, and then but the people that are in the virtual environment can interact with people that are in the real environment, and things like that. So I watched the first 2 seasons. Season 3 has just started, so if you like corny comedies that deal about tech and virtual people, whatever, give it a shot. Watch a couple episodes. If it's not for you, that's fine, but it works for me.
Excellent.
All
Great
right.
show today again. Thanks, Dejan, for coming and joining
for
and
having me.
sharing your experiences.
Yep. And if our listeners get in touch, what's the best way to ask questions or reach out to you?
I follow Twitter pretty much on a daily basis. So I'm also present on the GitHub discussions for RavenDB. So that would be probably the best place.
Yeah. I think some people are trying to call it Zitter now. Xitter. Instead of saying X, formerly known as Twitter, they just say Zitter. It's kind of funny. So, but yeah, for our listeners to get in touch with the show, they can reach me. I am .NET Superhero. I'm on Zitter. I am on Threads.
Oh, don't say Zitter, please. Zitter.com belongs to someone else. There's that countdown on that page.
Is there an
So please, it
Xitter?
could be anything.
Oh, okay. X, formerly known as Twitter. Yeah. And yeah. And then I'm also on Tribal as .NET Superhero. So any of those 3. Get in touch. Let us know what you think. Give us some topics or tell us that you want to be a guest on the show. Be glad to hear it. Thanks, everybody. And I'll catch you on the next episode of Adventures in .NET.
Bye, everyone.